Yes, sir, you're audible.
Okay, perfect. I think all of you are almost here, so we can get started. So, like I mentioned in the yesterday's class, today we'll be continuing with a few more questions on differential equations and completing the chapter. So, let me quickly begin with the screen share and start with the first question. So, the first question for today is if y of x, which is equals to lambda e to the power 2x plus e raised to the power beta x, where beta not equals to 2, is a solution of the differential equation such that y dash of 0 is equals to 5, then y of 0 is equals to how much? Option A 1, option B 4, option C 5, option D 9. So how should we start with this? Can anyone take a guess?
Sir, at first we should put the value of yx in the equation.
Okay.
Then
And that will give us what?
then we will find value of lambda. Sorry, the value of alpha and b. Sorry,
Beta is equal to -3
Okay. How are we getting that?
because we can see that from the that 2 and beta will be the two roots of the auxiliary equation, and solving that we are getting beta is equal to -3, and from that we can find the lambda by putting the solution in y dash 0 is equal to 5, and from there we can find y0 is equal to what?
Okay, so that means you are going directly with solving the differential equation first, right? That's how you're getting the auxiliary equation. So let y equals to e raised to the power mx be a trial solution.
Actually, we can see that directly that one of the root will be 2 and the other beta. So we can compare the coefficients and get that beta is equal to -3.
Comparing the coefficients with,
The auxiliary equation, of course.
yeah. So the process to get the auxiliary equation begins with the trial solution, right?
Oh, yes,
So
yes, yes, absolutely. Sorry.
yeah, yeah. So that means your dy by dx will be m times e to the power mx, and your dy by dx to m squared into e to the power mx. So that means if you replace the values, e raised to the power mx will be out m square plus m minus 6 is equals to 0. So e to the power mx not equals to 0. So that means your auxiliary equation is m squared plus m minus 6 is equals to 0. And if you solve this, what are we getting? M is 2 and minus 3, right? Correct? That means your solution, ideally, y of x should be c1 times e to the power 2x plus c2 times e to the power minus 3x, right? And exactly that is what is given as the structure of the solution is lambda times e raised to the power 2x plus e raised to the power beta x, right? Correct? Okay. So if you compare, what you can directly observe is that your beta will be minus 3, right? And C2 will be essentially 1. Correct? If you have to match it with the structure of the solution that is given to us. Yes? Is it fine with all of you? Making sense?
Yes, sir.
So that means basically from here, your y of x becomes c1 e to the power, sorry, c1 is lambda. So this is lambda times e raised to the power 2x plus e raised to the power minus 3x, right? So we need to find y of 0. So y of 0 is again lambda plus 1. So now I need to find out lambda, right? How can we do that?
So y0
Y0, sorry, what you were saying?
Y dash 0 is equal to 5 is given, so we have to differentiate the yx and then find lambda.
Yes. So y dash at x will be 2 lambda e to the power this minus 3 times e to the power minus 3x. Correct? So that means y dash of 0 is equals to 5. That means 2 lambda minus 3 is equals to 5. So that means lambda will be what? 4. That means y of 0 will be how much? 5. Okay, which is option C. Okay, is it understood by everyone? Any questions? Okay, so let's move on to the next one. Let y of x be a solution to the differential equation ddx of x into dy dx is equals to x. Y of 1 is equals to 0 and y dash of 1 is equals to 0. Then y of 2 is equals to how much? Option A, 3/4 plus half log 2. Option B, 3/4 minus half log 2. Becomes 3/4 minus. How can we proceed with this? Anyone?
Differentiating both sides, we will get a differential equation.
Differentiating both sides.
No,
Like
sorry,
differentiating,
it's
Sorry,
only
integrating both sides.
integrating both sides.
is that ddz or ddx the first one?
ddx, ddx, ddx.
Yes, we can differentiate the left hand side by ddx and keep the right hand side as it is. We will get a differential equation.
Okay, so if I do that, so you basically want to
So we
complete
have
this
to
derivative, right?
rearrange the equation.
Rearrange in what way?
So d of x dy dx is equal to 2x dx. Then integrating both sides.
Yes, correct. That also can be done. Just give me a minute. Sorry for the interruption. So let's come back. So I heard that two options that you all have made. So if I go by the first one, just wanted to discuss one small thing over here. So if you try to complete this differentiation first, so if I complete the left hand side, that will be something like this, right? Okay. Now, although this is a second order differential equation, agreed, but the coefficient of this second order derivative is a variable, right? It's not a constant. So if you try to go by the way that we have discussed, taking e to the power mx as a trial solution, you will not be getting a auxiliary equation directly that you can solve out, right? Because the x will be a variable. All right. So although completing the differentiation does give you a differential equation, but going by this way will be a little tricky. So we will not do this. Okay. Instead, we can do the other way around that I think someone else also suggested. So if I rewrite this equation as d of x times dy by dx is equals to x dx, I can simply integrate the first step. Okay. So if you do this, what will you get? This will be basically x times dy by dx is equals to x squared by 2 plus c. Correct? So from here, how can we proceed? Can anyone take a guess?
Sir, y dash 1 is 0, it's given, so we can just put in the values to find c.
Y dash 1 is equals to 0. That means when x is equals to 0, dy dx is, sorry, x equals to 1, dy dx is 0. So 0 equals to 1 plus c. So that gives you your c as, sorry, 1 by 2 plus c. So this will give you your c as minus half, right? So x times dy by dx is equals to x square by 2 minus half. So what can we do after this? What can be the next step?
Sir, again
Instead of
integrate both
dividing the
sides.
equation by x, we have to rearrange.
Okay, so I can write this in this way. So dy will be equals to x square minus 1, this, right?
Yes,
So
sir.
now I can integrate once. Correct. So what will I get? How? So the left hand side is direct. What about the RHS? How to integrate this?
Sir, x square by 4 minus half ln x plus c1.
X square by 4 minus half ln x plus c1. Yes, this seems to be correct. Now, how do we find out c1?
Sir, y1 is equal to 0 is given.
Yes, y of 1 is equals to 0. That means when x equals to 1, y equals to 0. So if you put this, what is your c1?
Half.
Half. half or shouldn't it be minus 1 by 4? Yeah.
Yes, the minus 1
Minus
by 4 is coming.
minus 1 by 4, right? So that means your final solution is x square minus 4, x square by 4 minus half log x minus. So what is your y of 2? That is what we need to find out.
Option C will be correct.
Option C,
Yes, sir.
3 by 4 plus log 2. এই মাইনাস একটা তো থেকেই যাবে।
Sorry,
So
sir.
3
Option
by
D.
4
Option D.
minus log 2.
Option
3
D.
by minus half log 2, right? এটা আসছে তো। This one, right? Option B. Okay. Any questions, anyone? Is this fine? Okay, so if this is fine, then let's move on. Is equals to 0, satisfying. Then y of minus 1 is equals to option A, y minus 1. Option B, option B, by 1 minus e. Option B, C. So how can we start with this? Can anyone take a guess?
So first we can arrange the differential equation.
In what way? Arrange as in? How do I rewrite it?
Sir, in the form of Bernoulli equation, we can rewrite it.
xy plus y raised to the power minus x dx plus x plus raised to the power minus x dy. So for Bernoulli, I need dy by dx form. So dy by dx will be minus of xy plus y plus e to the power minus x. They are getting this, right?
Yes, sir.
So after this step, what can we do for writing it in Bernoulli form?
So, we can like divide it like xy by the denominator plus e to the power minus x by the denominator.
Repeat once more. What will you write
So,
this? Yes, can you just tell me once more?
sir, like if I just remove the brackets, we can write it as minus xy plus y by the denominator
Okay,
minus e to the power minus x by the denominator. Then
okay.
we like taking y common from the numerator, we can take that part in the left hand side.
This you mean.
Yes, sir.
So this looks like a linear differential equation now, right? Not the Bernoulli, a linear. So over here, your p as a function of x plus 1 divided by x plus e raised to the power minus x, and your q as a function of x is minus of e raised to the power minus x divided by x plus e raised to the power minus x. So I need the integrating factor for this, which is e raised to the power integral dx. So e raised to the power integral. So how do we do this integration now?
Multiply numerator and denominator with e to the power x.
Multiply numerator and denominator with e to the power x. So I need to do this integration. I multiply numerator and denominator by e to the power x. Okay, and then if I do
So we
this,
can take substitution x plus e to the power x, we can take as u.
okay, so if you want to substitute, so this x plus e to the power minus x as some z. So 1 minus e raised to the power minus x dx is equals to dz. Now, how do I substitute it back? The denominator, but x plus 1 is there in the numerator, right? How do I get
Uh,
that?
yes, yes. This won't. I won't. This won't do it.
Yes, correct. This might not work. Anything else that we can do?
So e to the power minus x equals to 1 by e to the power x. Then we'll add it. Then it will come as e to the power denominator. In denominator, it will come as x into e to the power x plus 1.
That's the same thing, right? That we just did. And the e to the
I'm
power
trying
x
to
will.
nullify.
So this also, if you
Hmm,
substitute, now, are we getting anything?
I think yes.
Yes, we are getting. Right? This is correct.
correct, correct. Sir. Yeah. Now we can.
So e to the power x into x plus 1 dx will be your dz. So the integration will be simply 1 by z dz, right? So that is log mod x into e to the power x plus 1, right? So that means the integrating factor will be e raised to the power log mod x into this. So that means x into e to the power x plus 1, right? This is what we are getting.
Yes, correct, sir.
So now once we have got this, we will multiply the differential equation with the integrating factor. So this will be x into e to the power x plus 1 times this into y and this into x into e to the power x plus 1. So you will write this on the left hand side as d dx of y times the integrating factor. And the RHS will be minus of e to the power minus x, x into e to the power x plus 1 divided by x into e to the power minus x. And the next step would be d of y into x into e to the power x plus 1 is equals to minus of e to the power minus x, x into e to the power x plus 1 dx, and you integrate it. So the left hand side is straightforward. This will be y times this. What about the RHS? Anyone? How do I begin with solving this?
Multiply numerator and denominator with e to the power x. Yeah,
Okay.
it will cancel out.
Um, e to the power x this is what we are getting, right?
Correct, correct.
So that means y times x into e to the power x plus 1 is equals to minus x plus c. Now what will be c? We have an information y of 0 is 1. So that means when x is 0, y is 1. So 1 into 0 plus is equals to c. So c is basically 1, right? That means y of x into e to the power x plus 1 is equals to 1 minus x, typically. Here, y of x is nothing but. Okay. And what do we have to find out? What is y of minus 1? So what is y of minus 1? What's the answer coming?
2e by 1 plus c. 1 minus c. One minus c. Or 1 by e. 1 minus c. Yeah. No. 1 plus c, I guess. 1 plus c. Yeah. No. 1 minus 1 by e. E minus 1. E minus 1. 2e by e minus 2e by e minus 1. 2e by e minus 1. Yes, yeah.
Right? Okay.
Yes.
So which option is matching? B, right?
Yes, sir.
Okay. So is this fine with all of you? Any questions? Okay. And finally, concluding with the subjective question. So let y of x be a solution to the differential equation dy by dx plus y is equals to f of x for x greater equals to 0 and y of 0 is equals to 0, where fx is equals to 2 for x lying between 0 and 1, and it is 0 for x greater than equals to 1. We want to find y of x. Okay. So how can we proceed with this question? Anyone? What should we do? So the fx is given on the right hand side of the differential equation, right? And the functional value can be either 2 or 0 depending upon the range of x that we are talking about, right? So that means depending upon the range of x, you will have the two possible differential equations, correct?
স্যার বলছি
So
এটা কি
basically there,
বার্নৌলির মতো হয়ে যাবে? বার্নৌলি মানে ডিওয়াই বাই ডিএক্স ইকুয়াল টু মাইনাস ওয়াই প্লাস এফ এক্স, তাহলে ইন্টিগ্রেটিং ফ্যাক্টরটা ই টু দি পাওয়ার ইন্টিগ্রেশন অফ মাইনাস ডিএক্স।
বার্নৌলি কি করে?
মানে ওই ডিওয়াই বাই ডিএক্স মানে ডিওয়াই ডিএক্স কে রাইট সাইডে লেফট সাইডে রেখে বাকিটাকে ওই পাশে পাঠিয়ে দিয়ে তো সেখান থেকে ইন্টিগ্রেটিং ফ্যাক্টর বার করে তো ডিফারেন্সিয়াল ইকুয়েশন করা যাবে।
হ্যাঁ, সেটা করতে পারো, সেরকমও করতে পারো, বাট দুভাগে ভাগ করতে হবে, রাইট? The fx
হ্যাঁ
has
হ্যাঁ
two
হ্যাঁ হ্যাঁ,
different
ভাগ করতে
forms,
0
right?
টু 1
So
এর জন্য আর
there can
1
be
থেকে ইনফিনিটি।
exactly. So case 1, যখন for example x lies between 0 to 1, then my differential equation will be dy by dx plus y is equals to 2. This is your first differential equation. And for case 2, for x greater equals to 1, your differential equation will be dy by dx plus y is equals to 0, right? So basically there will be two possible cases or two different differential equations to solve to get to your value of x. Okay, so that means the y of x that you will get at the end will have two parts. The solution will take some form for x lying between 0 and 1, and it will take some other functional form, maybe for x greater equals to 1. Okay, got it everyone? Is it making sense? So this is what we need to do. All right, so the differential equation, I hope now you all will be able to solve this. It's a simple, relatively simple expression that is given. So there will be two possible answers that needs to be clubbed. So the yx can have two functional forms. All right. Is it fine with all of you? Making sense? What we have to do? All right. So I think I can put this as a homework for all of you. And we can come back and discuss the solution for this in the next class. And with this question, we conclude our discussion on the chapter of differential equations. Okay. So beginning the next class, we will be taking up a fresh topic, which will be the integral calculus portion. All right. So that's it for today's class, all of you. Thank you everyone for joining. See you all in the next class. See you all can disconnect. Thank you.
Thank you.